Good day, ladies and gentlemen. You are highly welcome to Shito's Mathematics Coaching Program. Before the commencement of today's lecture, I would like to beg you all, my viewers, if you look at this, you can see that it's been a while I drop my videos. So it's not because of anything, but I've been battling and being busy with some assignments on my hands. So I'm very sorry for any inconvenience. So today we are going to be looking at how we can get the derivative of trig inverse function. You can see they said we should find the derivative of sine inverse of x, understand? Then cos inverse of x, then tan inverse of x. That is, if y equals to sine inverse of x. Are you getting it? And if y is equals to cos inverse of x, and same time if y is equals to tan inverse of what? Of x. So now what is now the derivative of y here? What's the derivative of here? What's the derivative of y here? So that is what we want to be looking at today. So in order not to waste much of our time, so I would like to start from the first one. So starting from the first one, you can see that, let's say we have this to be this. Okay, let's say we have, you can see from here, y equals to sine inverse of x. So since we have y to be equals to sine inverse of x, you can see that we got this from s equals to what? S equals to sine y. Because if you look at it, if you want to know y here, understand, definitely it will be sine inverse. That's it, y will be equals to sine inverse of x. So we got this from what we have there. I'm getting it now. So now we are going to find the derivative of what? Of this with respect to x. So now getting the derivative of this, we have dx over dy to be equals to, what's the derivative of sine y? Sine y is what? Is cos y. Are you getting what I'm saying? So now from here, so what's the next thing to do? You can see that this is actually cos y divided by 1. So now taking the reciprocal, that is 1 over, that is what I mean by reciprocal of both sides, that is 1 over cos y over 1. Are you getting it? So you see that the reciprocal of this will be equals to dy over dx. That is, you are changing the position of what? Of the numerator and denominator. Understand? Equals to, this one will be 1 over cos y, because we have cos y over y here. So taking the reciprocal of this one, so this has to change. Understand? We have to change it by each other. Are you getting what I'm doing? So now from here we have dy dx to be equals to this. Call this one star star. So now from here you can see that what is the next thing to do here? The next thing to do here, because we have cos y, and don't forget that we have our s to be equals to sine y. So you now go to the trig identity that says sine square y plus cos square y equals to 1. You can see that from here we have what? We have cos y to be equals to 1, because if you want to make cos y the subject of the formula here, understand, this one we go to the other side, we have 1 minus sine square y. Are you getting it? Then all square root. I don't know, maybe you're getting what I'm saying. So now from here you can see that we have our cos y to be equals to this. So we now plug in this into what? Into equation star star. So we have dy dx to be equals to 1 over square root of 1 minus. So you can see sine square y is same thing as sine y all square. So which will be equals to this 1 minus, what is my sine y? I have my sine y here to be what? To be x. So I have x, then I have square here, l square. Automatically, so we have our dy dx, that is differential coefficient of y to be equals to 1 over this 1 minus l square. Are you getting it? So that is what? That is the solution to the first one. Are you getting what I'm saying? So that is what? That is the solution to the first one. So for the second one, if you have this, for the second one, you are asked to find the derivative of, that is, if y equals to cos inverse of x. So we adopt the same what? We adopt the same rule here. So you can see this is gotten from x equals to what? Cos y. Are you getting it? So this is gotten from this. Are you getting? Because if you are to make y the subject of your formula here, definitely this will be y equals to cos inverse of x and this. So we have that. Understand? So let's call it what? Let's call it 1. So now from there, what's the next thing to do here? So we differentiate with respect to y here. So we have dx over dy to be equals to minus sine what? Sine y. Are you getting it now? So now from here, so what's the next thing to do? So call this one equation 2. If this one is equation 2, the next thing we are going to do is to take the reciprocal of the two sides. Taking the reciprocal of the two sides means I want to interchange the numerator by the denominator. Understand? They will interchange themselves. So we have what? We have dy over dx, and the same thing applicable to what? To what we have at the right hand side, sine y. Are you getting it now? So we can see that this come up and this come down, this come up and this come down. Are you getting it now? So now from here, from what we did here, so we are going to do the same thing here also, because from this trig identity, so we can see that if you make sine y the subject of formula here, so we are going to have what? We are going to have sine y to be equals to square root of what? 1 minus what? 1 minus cos y all square. So now we are going to plug in this into this equation 3, so that we have dy dx equals to minus 1 over sine. So we are not going to write sine again because we've already said sine to be equals to this. So we have 1 minus. So what is my cos y? From what we have here, cos y is x. So we have x all squared. So which is the solution to what we have to find. Understand? That is solution to the problem we are given. So therefore we have dx of what? Of cos inverse of x to be equals to 1 over 1 minus x squared. I don't know if you are getting what I'm saying. So now you can see that this is having minus x. So therefore you don't need to disturb yourself anytime you are asked to find the derivative of what? Of trig inverse function. That is something like this. So now let's say from what you have, so the third one, that is tan inverse. So let's start by solving the third one. The third one said d dx of tan inverse of s, that is tan inverse of s. So if you want to look at this, you can see that what they are saying here is that we let this function, that is y, to be tan inverse of x. So now if y equals to tan inverse of x, automatically this is gotten from x equals to what? X equals to tan y. So call this what? Call this equation 1, as we did from the previous questions. So we have x equals to tan y. So now if x equals to tan y, so what's the next thing? So we are now trying to differentiate this equation 1 with respect to y. So we have dx over dy to be equals to, so derivative of tan y is what? Is z square y. So we have z square y. So to be the derivative of this. So let's call this one equation 2. So now from here, as we did from the previous problem, you can see that from here we try to, because we need dy dx, not dx dy. I get it. So we try to take the reciprocal of what, of both sides, so that y dy will come up, then we have dx. So that is the idea. Then automatically this one will be 1 over z squared y, because whatever you did to the left hand side, you must do it to the right hand side, irrespective of what you have. So you get what I'm saying? So now from here we have dy over there is equal to 1 over z squared y. So now from here, so what is the next thing to do here? Are you getting it? So you can see that we have, this is what, this is z squared y, z squared y, z squared y. So now same thing from the trig identity, z squared y is same thing as 1 plus tan square y. Are you getting it now? So since we have from the identity, trig identity, that z square y equals to this, so now we try to pick this. I put inside or employ this in what, in equation 3. So we have dy dx to be equals to 1 over, we've already said square y to be what, z square y to be 1 plus tan square y. So we have 1 plus tan square y. So now if this is equal to that, so we have what? We have 1 over 1 plus, but don't forget that tan square y could as well be written as this. So now from what we have up there, that is my equation 1, so we can see that my tan, that is 1 plus my tan is what, tan, but this tan y equals to what, x. We have x, then we have what, we have square here. So therefore d ds of tan inverse of x will give us what, will give us 1 over 1 plus x squared. So which is what, which is the general what, to general form. So this can as well, okay, so let me now bring this into general form. You understand? So if I should bring this into general form, let's say I have this. You know, I told you if you have sine inverse of ax, understand, that is, we are trying to find the derivative of this, of ax, you can see. So this one will be whatever you have here, your a over, because this one is for sine, 1 minus a square s square. Are you getting what I'm saying? Or you put it like this, a square. So this is what, this is the general form. And for the second one, if you have dx of cos inverse of ax, understand? So the same thing, this will be minus a over square root of 1 minus what, a s what, a s squared. Then lastly, for the tan, ds tan inverse of what, of x, as, let me say as, let's say we have constant that is multiplying this, so this will be 1 over, so it won't be 1, a to be a, I'm getting it, over 1 plus, this one is not having square root, so 1 as all squared. So you can see that is what, that is that. Now if you now has to solve for this dx of